Hello, welcome to THTV. In today's tutorial, we are going to look at end of semester past question measurement 2023. And please, if you've not watched our previous video that we made on end of semester past question on acid, base, and salt, please subscribe and watch that. Kindly try and watch that. So let's read the question together. Question 1. The period of oscillation of a nonlinear oscillator depends on the mass m, a restoring force constant k with dimensions of ml exponent minus 2t minus 2 and the amplitude a. Using dimensional analysis, drive an equation showing the relation among the variables. Question 1. Now the period of oscillation of a non-linear oscillator. So the period of oscillation of non-linear, once it is non-linear, it means that the period is inversely proportional. So the period is inverse, so that will be 1 over t is so our proportional sign. It depends on the mass, it depends on a restoring force constant k, and amplitude. So this is how you are going to represent that. This is what it means. The period of oscillation of a non-linear oscillator depends on, once the period is non-linear, it is inverse. So meaning that taking off your proportional sign, we will get, now any number over 1 is the same as t minus 1, right? So it's equal to, then we introduce a constant multiplying the mass, right? Then multiplying the k, multiplying the amplitude, right? Now what you do next is that you let the dimensions be x, y, and z. So let the dimensions be x, y, and z, right? So your dimensions are s, y, and z. So meaning that you will say t minus 1 is equal to k multiplying m in a. So this is how you are going to represent it. You assign your dimensions to the parameters in this way. So this one will take the y, and then the amplitude will now take the z, right? Then after that, you quickly replace the mass by its dimension, the k by its dimension, the amplitude by dimension. So t minus 1 is equal to k multiplying, the dimension for mass is capital M x, the dimension for k is given in the equation m l minus 2 t minus 2. Then dimension for amplitude is the same as length, right? So after this, you just expand the exponents to the bases. So what's going to happen is that you say t minus 1 is equal to your k, right, times, now x will come in power m, so we have mx, then we have what here, y, so y will come and power the first m, y, my, it will power the second l minus 2y, then to power the third t minus 2y, then z to power l, so lz. So from this stage, what you do is that you group like terms. Now indices, when the bases are the same, we add the exponents. So we have mass, so we add the exponents, we repeat 1, so x plus y. We have length and length, so repeat 1, then we add negative 2z, negative 2y plus z, then t stands alone, t is not having any so up to this stage we do what we call comparison, right? At first we have only t minus 1 here, By looking at the terms here, we have m and l. Once it is not here, it means they are raised to the power 0, 0. So we compare the t. So comparing the powers of the t, negative 1 now is equal to negative 2y, right? So we divide by 2, negative 2, we divide by negative 2. So we get our y value to be what? Our y value gives us half. Now let's compare the m exponents to find x. So 0 now is equal to x plus y. So meaning that when you make x the subject here, you get x now is equal to negative y. So negative y is simply half. So what we know that y is what? Half. So negative of the half is what? Negative half. So meaning that our x value is equal to negative half. Now let's compare the last term to find the z value, which is the l. So our 0 now is equal to, we have negative 2y plus z, right? So let's make z the subject. Making z the subject, you will get z now is equal to what? 2y, right? So we know y to be half. So z is equal to 2 multiplying half, right? So 2 multiply the 2a 1, that will give you 2 over 2, which will give you 1. So meaning that our x value is negative half, our y is half, and z is what? 1. Okay, so take note. So we are simply going to input this back into the general equation that we have, this particular one. So we will now see our final equation. T negative 1 is equal to k multiplying m. Now we know our x value, right? So x is negative 1, so raised to the power negative 1. Then the k raised to the power is y, so our y is what? Half. And then the a raised to the power z, which is 1. So we know that negative half can be 1 over half, right? And half is a root, so we can say that t minus 1 is equal to k multiplying 1 over root m, because the half will come down. It will be like we have something like 1 over half, so half is a root. So if that should be the case, then it will be 1 over root m multiplying root k, which is half, times a. So you could see that this is root, so they multiply, so you can quickly represent as k, then a root k over m, then you have your a here, right? So this is your equation. So finally, this is your equation. T exponent negative 1 equal to k root of, so the root is root of k over what? M multiplying the amplitude. So this is how you solve your a part. Equation 2, and we are to evaluate to the correct number of significant figures the following. So we have 337, right? 0.76. So we are adding it to 0.132. So 0 plus 2 gives us 2. 6 plus 3 will give us 9. 7 plus 1 will give us 8. Then our decimals. Then we have 7. So to the correct significant figure, the least significant figure here is 3. 1, 2, 3. So we leave our answer to 1, 2, 3. So our final answer will be 37.9. To the correct significant figure is 3 significant figures. So this is our I. Let's look at the II. We have 16.264. We are subtracting it from 16.26325. So 0 minus 5. So we borrow 1 from the 4. So here we'll be left with 3. Then it comes here to 10. Then we borrow from the 10 to the next one, so here we'll be left with 9. Then here becomes 10. Okay, so we have 10 minus 5, that will give us 5. Then we have 9 minus 2, that will give us 7. We are left with 3 here. 3 minus 3, 0. 6 minus 6, 0. 2 minus 2, 0. 16 minus 16, 0. So because our least significant figure is 1, 2, 3, 4, 5, it is advisable that since this is into two significant figure, you write it as 0.00075, then you add 3 zeros. So looking at the B part of the question, we have to find how many microbes make up 1 micrometer. But the question is saying that the micrometer, 1 micrometer, is often called the micron. So it means that if 1 micrometer is often called the microbes, it simply means that 1 micrometer is equal to what? 1 micron. So 1 micrometer is equals to 1 micron. So that is the I part. So let's look at the II. So the II, what fraction of a centimeter equals 1 micrometer? So let's say 1 centimeter now is equal to, let's just say, 1 micrometer. So the centi here is what? 10 exponent negative 2, and the micro here is what? 10 exponent negative 6. You see, like we are left with meter. Now what will I do to 10 exponent negative 6 to get 10 exponent negative 2? So if we multiply 10 exponent negative 6 by I think if you multiply it by 10,000, you will get that. So 10 exponent negative 6 is equal to 10,000 multiplying 10 exponent negative 6. You get 10 exponent negative 2. So it means that when you fold it back, it means that 1 centimeter is equal to 10,000 micrometer. So its fraction is simply 1 over 10,000. So let's look at the C part of the equation. We have to calculate the growth rate in micrometer per second, and they've given us 3.7 meters and 14 days. We are going to convert the 3.7 meters to what? Micrometer, and 1 meters is equal to 100,000 micrometer. So meaning that 3.7 will be equal to what? So 3.7 times 1 million in micrometer will give you 37 1 2 3 4 5 zeros micrometer. So we have changed the 3.7 meters to micrometer. So we are going to change the 14 days also to what? Seconds. We know that one day is 24 hours, right? And 1 hour is equal to 3,600 seconds. So meaning that if 1 hour equal to 3,600 seconds, then in a day we have 24 hours. So it'll be 24 times 3,600, and you get a value of 86400 seconds. So if you should multiply, this is a day, so we multiply this by 14 to get the 14 days. So 14 days in seconds is equal to 1209600 seconds. So we divide to find the growth rate. We divide the what? So to find the growth rate, we divide the value we found in micrometer, 37123450 in micrometer. We divide it by the seconds, the 14 days in seconds, 1209600. So when you divide that with your calculator, you get 3.0 0.05. So approximately, let's say we get 3.1. So this is the growth rate.